Okay, dear students, once again, welcome back to you with another interesting chapters of your class 10 mathematics for your term 2 examination. And all of you can see, I'm going to discuss the chapters arithmetic progression, which is one of the most interesting chapters and lucid chapters, okay, and vital chapter for your class 10 examination for your term 2 examination, right? I hope you will enjoy the class and you will go through again and again, okay, and you will apply it in solving problem, okay. So let me start with the class here, and mathematics class 10 arithmetic progression term 2 examination, okay. So first term I am going to discuss what is sequence. Yes, here you see what is sequence. Yes, a sequence is a group of numbers. A sequence is a group of numbers. A sequence is a group of numbers. Yes, sequence is a group of numbers arranged according to a definite rule is called a sequence. Yes, a group of numbers arranged according to a definite rule is called a sequence. Okay, is called a sequence. Understand? So another term is term. What do you mean by term of the sequence? What do you mean by term of the sequence? Each number in the sequence is called term. And the terms are usually denoted by the letter A1, A2, A3, okay, up to AN, or sometimes it can be denoted by letter T1, T2, T3, T4 up to Tn. Okay, understand? Is it clear? Now see, let us write some example of sequence. First you write you see I'm writing here 1, 2, 3, 4, 5, 6. It is a group of natural numbers. So it is an example of sequence. S is an example of sequence. Okay. Yes. Similarly, 2, 4, 6, 8, 10. The set of even natural numbers is another. Yes, is another example of sequence. Similarly, I can write 1, 3, 5. The set of odd numbers is 7, 9 is another example of sequence. Yes. Okay. And here write 5, 10, 15, multiple of 5. Yes. 20, etc. Another way of sequence. You can write here 1, you can write 7, yes, 7, 14, 21, yes, 28, etc. is another sequence. Okay, these are some example of sequence and for you. And here in the sequence you can see each number of the sequence is called a term. Here you see, here the first term is 1, in the sequence first term is 1. Okay, and here in the sequence first term is 2, here in the sequence first term is 1, and in the sequence first term is 5, and in the sequence first term is 7. Okay, and here you see, and in the sequence the first term is second term is 2. Yes, and here second term is 2, here second term is 4, here second term is 3, here second term is 10, here second term is 14. Yes, and here the third term is 3, here the third term is 6 in the second sequence, and in the sequence the third term is 5. Yes, so in this sequence what is the third terms, which is 15, and in the sequence the third term is 21. So okay, so these are the example of sequence, and each term of the sequence is called a term. Okay, Is it clear? Understand? So you see here, you can write in the sequence. For example, I am writing the sequence 1, 2, 3, 4, 5, etc. Understand? So in this sequence you see the difference between the two consecutive terms is always each 1. The difference between the two consecutive numbers is always 1. 2 minus 1. You see 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. You see 2 minus 1 is 1. Yes or no? Here you see 3 minus 2 is 1. Understand? It means the difference between the two consecutive terms is always 1. If you are finding the difference every term to its preceding terms, okay, the difference is 1. So this is a pattern of numbers arranged in a definite orders. So we can say this is an example of sequence. Okay, and in the sequence you can see the first term a1 is equal to 1. Okay, and here the second term, what is the second term size? 2. And here third term is what? 3. Yes, understand? So you see now here fourth term is what? 4. And fifth term is what? 5. Yes. So these are the terms of the sequence. We can usually denote it by the letter A1, A2, A3. The terms of the sequence is usually denoted by letter A1, A2, A3, A4 up to AN. Okay, understand? Similarly, another sequence we can write here the set of even numbers 2, 4, 6, 8, 10, etc. Okay, and if C, and here in the first term is what? A1 is equal to 2. Yes, the second term A2 is equal to 4, and third term A3 is equal to 6. Yes, and the fourth term A4 is equal to 8. Understand? And if you find the difference between the two terms, you see now A2 minus A1. You can see here 4 minus 2 is 2. Yes, and A3 minus A2. You're finding the difference of every term to its preceding term. Okay, A3 minus A2. Okay, the preceding term of A3 is A2. A3 minus A2 is equal to 6 minus 4 is also 2. So here you see the difference between the two consecutive terms. What is the difference between the two consecutive terms? Each 2. Okay, understand? Similarly, you will see A4 minus A3. Okay, it will be the fourth term. Fourth term is 8 minus 6 is also 2. So this is also group of numbers arranged according to definite rule in such a manner that the difference between the two consecutive terms is always 2. So we can say this is an arrangement of numbers, or this is a group of numbers arranged according to certain rule. So, and here we can say that 2, 4, 6, 8 and so on is an example of sequence, and this is a set of even natural number also, all of you know. Okay, similarly another example you see now, we can write another sequence 1, a set of odd natural numbers 1, 3, 5. Okay, what is the next number? 7. Yes, the next number is what? 9, and so on. Okay, and you see here first term is what? Is the first term is 1. Yes, and what is the second term? Is 3, and here third term is what? What is the third term here? 5, and here fourth term is what? 9. Here fourth term is 7. Here fourth term is what? 7, not 9. Fourth term is 7. You see? Yes. Okay. Understand? You see first term is 1, second term is 3, third term is 5, fourth term is 7, and fifth term is 9. Okay. And if you see carefully, you see the difference between any terms to its preceding term, A2 minus A1, which is equal to 3 minus 1, which is 2. Yes. Similarly, A5, A3 minus A2. Yes, which is 5 minus 3 is also 2. And you can find here the difference between any terms to its preceding term is always 2. So here is a setup. This is arrangement of numbers. This is a group of numbers arranged according to fixed rule, definite rules, and in such a manner that the difference between the two consecutive terms is always 2. Okay, it means if you find the difference every term to its preceding terms is always 2, the value is always 2, so we can say this is a sequence. Is it clear? Understand? Okay, but here you see now another example. You see, okay, you can see another example. Here you see 5, 10, 15, then next term is 20, the next term is 25, and this is a group of numbers, is a multiple of 5. You can clearly see, and you can find the you can see the difference between the two consecutive terms, and is always 5. Yes, a2 minus a1, what is the value? Tell. 10 minus 5, yes, 10 minus 5 is 5, yes. Then a3 minus a2, a3 minus a2, 15 minus 10, 15 minus 10 is also 5. Then a4 minus a3, 20 minus 15 is also 5, yes, is also 5. And here this is a group of numbers and is arranged in such a that the difference between the two consecutive terms, it means the difference between any terms to its preceding term is always 5. So we can say this is a sequence. Yes, is it clear about the sequence? Yes. Okay, so next concept we are discussing about the progression. What is progression? Let's see. What is progression? What is progression? Yes, can you tell me what is progression? Okay, and progression is a sequence. A sequence whose every terms okay, can be, so its every terms can be described or can be explained by an explicit formula. Explicit means general formula. Explicit formula, unique formula, or by general formula. Such type of sequence is called a what? Is called a progression. Is called a what? Progression. Understand? Is it clear? So a sequence whose every term can be described, can be explained by an explicit formula or by a general formula, and such type of sequence is called a progression. Okay, understand? Is it clear? Okay, and you see, for example, I am writing a setup. You see now, writing a setup sequence. I'm writing 1, 2, 3, 4, 5, etc. So can you say this is a progression? Okay, this is a sequence, all of you know. Can you say is it a progression? So if the sequence can be expressed, instead of writing all the terms, we can, okay, in every terms of the sequence can be expressed by general formula, by explicit formula. Okay, unique formula. Then such type of sequence can be called a progression. Let's see. You can see clearly. Here you see the sequence is 1, 2, 3, 4, etc. If you see carefully, so if I will ask you, what is the first term? When you see here, when n is equal to 1, we can say the first term. What is the first term? A1, which is 1. Similarly, when n is equal to 2, here you can a second term, you can get second term is 2. Yes or no? Similarly, when n is equal to 3, yes, we shall get the third terms. What is the third term? Say 3. In a similar manner, if you proceed when, okay, if you proceed in a similar manner, yes, when n is equal to what? When n is equal to n, so we shall get the nth term. Which is denoted by letter an. The value will be what? N. So here you see the an is equal to nth term is the general term. Nth term is the general term. Or is the explicit formula, is the general term, is the general term of the sequence. General term. Okay. Understand or not? So if every sequence can be expressed by general term or general formula, we can say general formula. General term is also known as general formula. Yes, general term, and here the an is equal to n is the general what formula? We can say general formula. Okay. So if every sequence can be expressed by general formula, then such type of sequence is called a progression. Is it clear? Or if every term can be explained with the help of general formula. Suppose I am writing and in the reverse manner. Suppose I am writing, yes, suppose an is equal to what? N. Yes, is a single general formula. So we can write can I write a sequence with the help of this general formula? Okay. And with the help of this, we can express the set of what? Set of natural numbers here. Set of natural numbers we can express. Understand? So an is equal to n is a general formula by means of which we can explain every terms in the set of natural numbers. Yes or no? Yes, because you see when you see here when n is equal to 1, you shall get what? You see when n is equal to 1. Look at here. When n is equal to 1. Yes, when n is equal to 1, you see now we shall get the first term a1 is equal to what? Can you replace the value of in place of n? Can you write 1? Okay, we shall get the first term. Similarly, when n is equal to 2, and we shall get the second term in place of n. Can write 2? Yes. And similarly, when n is equal to 3, we shall get the third term, which is 3. Understand? Suppose n is equal to, if you write 25, we shall get the 25th term of the sequence, which is 25, and this is the 25th term. This is the 25th term of the sequence. And this is the first term. Yes, first term. And this is the second term. And this is the third term. It means, and this is, you see, very interesting formula. This is an is equal to n. Okay, this is the general term of the sequence or a general formula with the help of which you can express the sequence 1, 2, 3, 4, etc. and every terms, okay, of the in the of the sequence. Yes, so and 1, 2, 3, 4, etc. is a progression. Can you say? Similarly, another example I can tell you. The set of even natural numbers, suppose 2, I can write 4, 6, 8 in a similar manner. Okay, and you say when n is equal to 1, you shall get the first term. What is the first term? Can you tell what is the first term? The first term is a1, which is 2. Yes. Okay, and you can write also 2 means 2 into 1. Yes or no? Yes. Similarly, when n is equal to 2, we shall get the second term. Yes. What is the second term? Second term is 2, and here second term, can you see a second term is 4? Clearly say, can you modify it? 4 is equal to 2 into 2. Understand one interesting fact you see here. Here when n is equal to 2, second term you are getting a2. You see this number 2 is related with this number. You see when n is equal to 1, here 1 is related to what? 1. Okay, are you finding some interesting fact here? Yes. Similarly, when n is equal to 3, we shall get the third term. Which is a3. Okay, number of terms 3. So here we shall get the what is the third term? 6 is the third term. Yes. 6 is the third term. Yes. Understand? Yes. So we shall get 6, and which is can be written as 3. 2 into what? 3. 2 into 3. And when the number of terms is 3, and we shall get so third term is what? You see, and here you can compare this number here. 2 into 3. Similar manner, when n is equal to 4, we shall get the fourth term. Fourth term is what? 8, which is 2 into 4. Yes. Understand? Similarly, when n is equal to 5, we shall get the fifth term. Can write 2 into 5, which is what? Which is the fifth term? 10. Understand? Similarly, when n is equal to 6, we shall get the sixth term, a6, which is 2 into 6, which is equal to how much? 12. Understand? Similarly, when n is equal to 7, we shall get the seventh term, a7, which is known as 2 into 7, which is 14. Yes. Understand? We can express any terms of the sequence. Similarly, when a is equal to 25, 25th term, we shall get 25th term. So 25th term, a 25. Can you say a in 25? 2 in 25. Yes. Which is how much? The 50. Similarly, when n is equal to x, can you write? We shall get the x term, ax, 2 into x. So here is equal to x. So we are getting a general formula. Similar manner, if you proceed, when n is equal to n, we shall get the nth term. We shall get the nth term, which is n is equal to 2 into what? 2 into n, which is 2n. Understand? Thus we are getting here. So a nth term, an, is the general term which is represented by 2n, is the general formula with the help of which we can express the every terms of the sequence. Okay, and the sequence 2, 4, 6, 8, 10, and so on. This is the set of even natural numbers can be expressed by the single general formula 2n. Is it clear? Understand? Since every terms of the sequence can be expressed by a single general formula, explicit formula. So 2, 4, 6, 8, 10 is a progression. Can you say it is a progression? Yes. Let's check. Okay. The general formula, what is the general formula? An is equal to n. Yes or no? Let us check. Okay. So when n is equal to 1, you shall get the what? First term a1, which is 2 into n. 2 into 1 is equal to what? 2. We are getting first term. Yes. Similarly, when n is equal to 2, we shall get the second term a2, which is 2 into 2, which is 4. So we are getting set of what? Even natural numbers. Okay. Similarly, when n is equal to 3, we shall get the third term, which is 2 into 3 is equal to how much? 6. In this manner, if you are getting proceed in this manner, n is equal to suppose 10 I am writing. We shall get the 10th term. Can you say what is the 10th term? Yes. 2 multiply 10, which is what? 20. Yes. Okay. Thus, we are getting a sequence and which sequence is 2, 4, 6, 8 up to dot and so on. So this is and the last term will be 2n. Yes or no? And here 2n is the general formula with the help of which you can express the every terms of the sequence. So the sequence, so the given sequence, the sequence 2, 4, 6, 8 is can be a progression, is a progression. So any terms of the sequence can be expressed by a single formula, by unique formula, by general formula is called a progression. So is a progression. Is it clear? Understand? Yes. Similarly, can you tell? Okay, you see now, suppose I am writing another sequence. Let's see. Sequence 2, 3, 5, 7, yes, 11, 13, and so on. Can you say what kind of sequence? It is a set of prime numbers. Is a set of prime numbers. Is a set of prime numbers. Yes or no? Set of prime numbers. It is a sequence, but is every term cannot be expressed by a general formula, by explicit formula. That's why, okay. So every terms of the is not a progression. Is not a progression. It's a sequence, but it's not a progression. Why it is not a progression? Because the terms cannot be explained, cannot be described by an explicit formula, by a general formula. Okay, so this is not a progression. Is it clear about the sequence and progression? So you can clearly understand, you are getting some idea about that every progression is a sequence. Every progression is a sequence. Yes, every progression is a sequence. But every sequence is not a progression. Every sequence is not a progression. Is not a progression. Yes? Understand? And a sequence can be a progression under what condition? If the terms of the sequence are explained, if every terms of the sequence can be explained by a single general formula or by an explicit formula, then such type of sequence is called a progression. Understand or not? So progressions are few. So progressions are few. So progressions are few. There are few progressions are there. Progressions are few. Yes or no? But sequence are many. But there are many sequence. But sequence are many. But sequence are many. You can say. So there are few progression and okay, and we shall discuss some types of progression is that. What are the types of progression you see now? Types of progression. There are three types of progression you will study. One is the arithmetic progression. We are going to discuss about this important concept of arithmetic progression. Okay. Yes. So we have discussed in these chapters arithmetic progression. Another progression is known as what? Second progression is known as AP, you can say. Yes. Another progression is known as, second point is known as geometry progression. Geometric progression. Understand? Third is known as harmonic progression. Harmonic progression. Understand? and by combining the arithmetic and geometric progression we shall get another progression is known as arithmetico-geometric progression. Yes, arithmetico-geometric progression. Yes, so these are some the types of progression we are going to discuss, but okay, what we will discuss as per your syllabus arithmetic progression. Okay, so these are some of the concepts regarding the introduction, regarding the sequence and progression and types of arithmetic progression, and in this class we discuss, and in the next class we shall discuss vividly about the definition and the examples of the arithmetic progression and how can we derive the general form of the arithmetic progression. Okay, we shall go vividly. So I hope these are the some introduction about the sequence and progression and types of arithmetic and types of progression. Okay, students, I hope you will. Okay, let's see once again this one. Yes, you see here, you see, and we're discussing the arithmetic progression of mathematics class 10 term 2, and here the sequence. Okay, let's see once again. Yes, these are the sequence here, and here the terms of the sequence. Here first term, second term, third term of the set of natural numbers. Here the set sequence of set of even numbers. Yes, and here the set of sequence of odd natural numbers, and here the it is a sequence is a multiple of 5, and here what is progression, it is in front of you. Okay, sequence whose every terms can be described by an explicit formula is called a progression, and here the set of natural numbers, and here the n term, a general formula of the sequence is an. Okay, understand, look at here, and here general formula is an is equal to n. Okay, through which we can explain and every terms of the set of natural numbers. Okay, here is a set of here sequence of even natural numbers which is a progression because its general formula is what, 2n. You see, because the general formula is 2n, because every terms can be explained by general formula what, yes, 2n. So we can say here 2 4 6 8 10 is a progression, and here 2n an is equal to 2n is the general formula of the sequence. Okay, and with the help of which we can describe, we can explain the set of even natural numbers. So the sequence of even natural numbers is a progression because the every terms can be explained by an explicit formula 2n. Okay, and here here the set of prime numbers is not a progression. Why? Because its terms cannot be expressed by single general formula or by explicit formula, by unique formula. That's why the set of prime numbers is not a progression. So thus we clear that every progression is a sequence, but every sequence is not a progression. So the progressions are few, but sequence are many. Here we are discussing the types of progression and arithmetic progression, geometric progression, harmonic progression, and on the combination of arithmetical and geometric progression we shall get arithmetico-geometric progression. Okay, and in the next class we shall discuss your arithmetic progression in vividly. Okay, thank you students, and so thank you, and watch again and again this class. Okay, and get some introduction about the idea, the basic idea about the sequence and progression. Okay, thank you, see you, bye.